I am Saurabh Kumar. I did my bachelor's from NIT Jaipur in architecture and master's from IIT Kharagpur. And I will be helping you guys in preparing for your NATA or JEE, whatever you guys are preparing for. And in today's class, we'll study about the visualization of 3D objects. I'll tell you about this topic, about the subject, its importance as per the perspective of both JEE and NATA. Also, I'll tell you what are the different sections that are there in this head that you are having, what kind of questions you can expect from them in the exams, what kind of questions were previously asked on different topics, what kind of emphasis the test conducting authorities give. So all these things we will discuss about. So as we have some new students, please confirm if you are visible with my English, or if you want, I can also switch to Hindi, or we can use both the languages. If you think the flow is like fast or slow or anything, you can discuss, you can tell that also. Flow is good. Okay. Comfortable with both. Thank you. Even in the middle of class, if you ask me to, sir, please explain this concept in Hindi or something, then I can do that also. Our only basic idea is you guys should be comfortable with the topic. You should get clear with it. And at the end of class, you should have the confidence that you can attempt the questions that would be asked in this. So if we start with it and look at the 3D objects and our two exams, NATA and JEE. Also, most of you guys are like who are in 12th this year. So are most of you those who just recently got their result, board result, like yesterday, I guess? So you guys are happy or in some kind of trauma or something, means as per the result?
Sir, it's okay.
Okay, so first thing that we see about the 3D objects and NATA JEE, let's look at its importance as per the exam point of view. So for this, we can say that this is very important for your exam. The reason I'm saying that very important, because on an average, you can expect like 8 to 10 questions. The questions could be more than that also, because in this kind of aptitude, we have different sections. So if I tell you in the subsequent slide about 2 or 3 topics differently, so from each topic you can have 3 questions or 4 questions. So the question count can go more than this also, but from the weightage that this topic is having, we can say that it is very important. Now, in these questions, the type of questions that could be asked based on 3D objects, in 3D objects, we need to understand their plan, their elevation, their view. Have you guys heard about these terms? Like what is a plan? What is an elevation? Anything?
Yes, sir. Yes, sir.
Then we'll also see about having some 2D view, and then we need to convert it into 3D. Or it can also be vice versa. So any kind of questions could be there. So this was the overview of the topic that we will study and its importance as per these 2 exams. Clear till now?
Yes, sir. Yes, sir.
Kindly respond either in the chat box with a yes, no, maybe.
Yes, sir.
Yes, sir.
Okay. So let's look at the syllabus overview. Now here I'm telling you about the syllabus of this topic, not what we will cover in today's class. So if you go through your study material, you can look at book 4. This book 4 in study material is basically about the orthographic projections that we will study. The title of this book is Visualization of 3D Objects. So in this different things that we have, first one is orthographic projections. Don't worry about its name. I'll explain in detail what this orthographic projection means. Basically, talking about your views, you are having something in 2 dimension and then you need to imagine it in 3 dimension. So that part is in orthographic projection. Then we have counting surfaces. Basically, they will give you some kind of 3-dimensional object and they can ask you to count the surfaces that are there on the object. Not just the surfaces, these could also be the vertices or the edges or your surfaces or the faces, you can say. If you guys are not familiar with any of these words, you can ask. It's like if we have the cube, so these are the vertices, then this is the edge, and then this face, it's the surface. So this is what counting surface is. Then there is another concept in which you need to count 3D objects. There could be different blocks. You can, for this part, you can think of, have you guys heard about the game Jenga? In which, you know, there are these different cuboids stacked one over other and you need to pull any one of it. So in this topic, they can give you a view of Jenga and they can ask you to count the blocks in that. So basically you need to look for the blocks that are visible to you, and also you need to imagine the blocks that are not visible to you, means that are on the opposite side of it. Then we have surface development. Surface development is, this is the technical term, surface development, that we use. For easy, you can think of folding and unfolding. Remember in our weekend newspapers, we sometimes get such kind of quiz or questions in which they gave an open surface like something like this. And then they ask, if we fold all these surfaces, what we will get? So such kind of questions are there in surface development. Obviously, NATA or JEE won't ask you questions such simple, but this is the basic idea of the concept. And after all this, we'll look at some of the previous year questions. So in these 2 slides, the overview that I gave you is about the visualization of 3D objects. In today's class, we will cover this part, the first one, orthographic projections. So the structure would be, I'll tell you the concepts of orthographic projection. After that, we'll together solve some of the practice questions. And then after that, we'll look at some of the previous year questions. So we'll try those questions also. And if you look at the overview, so first thing, are you guys familiar with the layout or the interface of the app, the KP architecture app, all of you?
Yes, sir.
Okay.
Yes, sir.
So the process that you should follow, that I would also recommend, is that try to take notes in this class, try to understand all these concepts at this moment. After this, you go on your app, you look at the study material, and there the study material is there. Go through all of that again. All this lecture that we are taking, it would be in recorded lecture, so you can refer that also. The assignment would be uploaded, the test would be online, so attempt those also. And this way we can say that this topic would be covered. So all clear till now? Can we now start with this topic,
Yes, sir.
orthographic projections?
Yes, sir.
Thank you. So first thing, this orthographic projection means you are trying to represent any three-dimensional object in your 2D view. Basically, you have some 3D object in your hand, maybe your Rubik's cube, and then you are drawing it on your paper. So that method, that way of presentation is the orthographic projections. So if we have to write about it, it is a means of representing a three-dimensional object on a plane surface. So basically in this topic, we'll try to understand how they represent those 3D objects on the 2D surface. There is the exact reverse situation also. They'll show the 2D objects and then they will ask what is the 3D object for it. So when we try to represent a 3D object on a plane surface, there are different views. Like the first one is a top view. Then we have a front view. And we have a side view. These front view, side view, these could be called as the elevations. Front elevation, side elevation. This top view could be called as the plan. Remember in one of this slide description, I told you these plan, elevations, and views. So this is basically these terms. If let's look at an image and try to understand them from there.
Sir, please wait. I can write.
Okay. You want me to stay on this slide?
Yes, sir. 1 minute only.
No, okay. You can take your time.
Okay, sir.
Okay. So let's look at this image. In this image, these dots are basically the grids which are used to draw it. And for our understanding, it is having these different colors on all the sides. So we are looking from top. So this is called plan or the top view. Then this side is considered as the front. So it's a front view. And this side is the side view. Means this side will give us the side view.